You're listening to episode 180 with Jeff Gregory.
Welcome to the Gemba Academy podcast, the show that's focused on helping individuals and companies achieve breakthrough results using the same continuous improvement principles leveraged by companies such as Toyota, Del Monte, and the U.S. Department of Defense. And now, here's your host, Ron Pereira.
Hey there, this is Ron Pereira with Gemba Academy, and I'd like to welcome you to another edition of the Gemba Academy podcast. As always, thank you so much for taking time out of your day and your week to listen to the show and for watching our Lean and Six Sigma training videos over at GembaAcademy.com. We definitely appreciate each and every one of you. Now, today I'm excited to welcome Jeff Gregory to the show. Now, Jeff is as a consultant today, but he's got a really, really strong background in industry. He worked at kind of tier one automotive companies, and he's been a general manager, plant manager, maintenance manager. You can name it. He's probably done it. So tons of experience. And today we really dove into the topic of TPM, or total productive maintenance. Now, if you're not in kind of a manufacturing world, before you check out and say, oh, this one's not for me, I'm going to go listen to something else, I want you to stick with it a little bit, because the things that we talk about, while that was definitely more manufacturing focused, I want you to listen to the way Jeff talks and presents himself, and just the way he thinks about things. It was really inspiring to me. Now, we did get all into TPM. We talked about what it is. We talked about some of the foundations and pillars of TPM. Talked about some of the mistakes folks make when they go about a TPM program. Then we really got interesting was we got into kind of the difference between what Jeff refers to as preventive maintenance and then predictive maintenance. And then on the predictive maintenance side, we really got into some cool stuff like thermography and how you can kind of predict failures before they occur. We talked about key performance indicators, and then we had a really good chat on OEE, or overall equipment effectiveness. So it was a really, really good show. I really enjoyed chatting with Jeff, and I think you're going to get a lot out of it. Show notes for this episode, which will include links to every ways to contact Jeff on LinkedIn and so forth, can be found over at GembaPodcast.com. Just look for episode 180. Again, GembaPodcast.com. Look for episode 180. Also, just our normal plug for the AME conference that's coming up. If you're planning to go to the show and you haven't bought your tickets yet, go to GembaAcademy.com/AME, and you can save 10%. And most importantly, you can sign up for our cocktail party, which is going down on that Tuesday night, which Jeff is going to be attending. So you'll get to meet Jeff in person if you go to the cocktail party. So again, that's GembaAcademy.com/AME. Okay, enough from me. Let's get to the show. All right, Jeff. Well, thank you so much for coming onto the show. Where are you calling in from?
Lynchburg, Virginia.
I
really appreciate you letting me be on the show this morning.
Yeah, my pleasure. My pleasure. All right. Well, Jeff, as you know, we like to kind of get things rolling at the start with our guest sharing a quote or two of something that possibly inspires them. So do you have one?
I sure do. So George Lichtenberg said, I cannot say whether things will get better if we change. What I can say is we must change if they are to get better. And to me, that means a lot, because I think so many people are afraid of change, but they do want to see things get better. And I think if we embrace that change, like he was saying, that we can see things improve over time.
I love it. I love it. All right. Well, Jeff, catch everybody up a little bit on your background, maybe how you first came to learn about all this continuous improvement stuff that we do, and tell us what you're up to these days as well.
So years ago, I worked for a tier one automotive supplier, and I hadn't heard anything about lean. I had just gotten out of school, and we began our lean journey way back in like 2002, and I was a maintenance manager. I was vying for an engineering manager position, and had a lot of maintenance guys working for me. We worked 24/7, and obviously in tier one automotive, it's pretty important that you have good equipment reliability, good processes. Obviously with TS 16949 and things like that, we began our lean journey, and I was named TPM champion. And so I started reading everything I could get my hands on related to lean, and I picked up a book called Installing TPM in a Non-Japanese Facility by Edwards, and that book really changed the way I looked at a lot of things. And it really made me start to think about how not only can lean transform a production environment, but it can certainly transform a maintenance and engineering environment as well. And from there, I just began to learn as much as I could about operational lean as well, getting into those things that will obviously eliminate waste and improve your output, improve your cost. These days, I started out as a maintenance manager for that company, and then I continued to move up in my career. Most recently, I was director of manufacturing for a large organization here in Lynchburg. I've been a general manager and plant manager over the years, and through that time, continuing to learn about lean, and as well as lean, applying Six Sigma as well. And I have seen plants be transformed through lean a number of times. These days, I'm actually doing lean consulting. So I work for OPX Solutions, and we do lean manufacturing consulting and leadership development. And so we're practicing these principles every day in what we do with our clients.
Nice. So are you more on the kind of the TPM side, or just lean in general? Lean
in general, really. We really start out with a value stream map, and then we drive to improvements where they're identified on the value stream map. So, for example, you may have one client that has a real need to improve reliability. We'll, at that point, implement TPM and equipment reliability tools. Other focuses, somebody might need improvement in quality. So we take a look at those areas where we can improve that using lean tools and Six Sigma tools.
Got it. All right. Well, so I guess the topic of the day that we're going to focus on here, Jeff, is TPM, or total productive maintenance. So let's kind of begin at the start, as they say, and just give us an overview of what is TPM.
Well, TPM is really, in general, the program is intended to get all of your operators from the production floor involved in TPM. Most organizations have very few maintenance guys, and they always feel like they don't have enough. But if you can apply the TPM principles in getting your manufacturing associates involved in non-invasive maintenance activities, then you really have a much larger group studying things like wear and looking for predictive opportunities to improve your equipment. In addition to that, it's really important to get your engineering group involved in that in the front end, as well as your leadership, because TPM is specifically about getting more people involved in the reliability of the equipment on a daily, weekly, monthly basis.
Yeah, in my experience back when I worked in industry and practicing TPM, the thing that always appealed to me, and I don't know who was first in this, but I almost feel like the TPM community grasped the whole idea of autonomy with autonomous teams and things like that before anyone. We spend a lot of time talking about autonomy now, just in general, like don't solve everyone's problems, like, and on a day-to-day basis, make them think and challenge them with questions and be Socratic and so forth. But yeah, the TPM world really seemed to figure this out. I would say before everyone, in my opinion. I don't know if that's 100% accurate, but just kind of my perception.
I would agree with that.
Yeah. All right. Good stuff. Hey, so let's just kind of get into maybe the foundations. There's a famous kind of picture with the pillars of TPM. Let's talk a little bit about that foundation and those pillars.
Well, obviously, the first thing you want to do when you're looking at a TPM program, the foundation of TPM is really your 5S. It's really important to have a good 5S program in place in order to facilitate TPM. And the reason for that is once you have everything in order, you have everything cleaned, so obviously the effects of the 5S on the workplace, it's important to have your process as visual as you can, have abnormalities easily identified. So the 5S becomes really the foundation of the TPM structure. Obviously, then you move into safety and health and environmental. You want to be able to eliminate risks, and you want to put the emphasis on achieving really zero injuries. I heard somebody say one time in the safety world, if you can go a day without injuries, then you can go a week, and if you can go a week, a month, and a month, a year. And so you have to think about it like that, make it, take it to the smallest level.
Mm-hmm. Talk about some of the other pillars as well.
Sure. The training and education is a big piece. And I think this is where a lot of people have some struggles with their TPM journey. The first thing you have to do is you got to make sure your maintenance personnel are trained so that they can really capitalize on the predictive and preventive maintenance processes. Mm-hmm. If you have less skilled maintenance folks, they're going to struggle when it comes to training operators. And obviously, the second piece is you need to train your operators to be able to identify abnormalities. And in the real world, where we implemented this, we were able to develop a tactile environment where they could go in and really put their hands on different kind of cylinders, different kind of PLCs, different kind of photo eyes and proc switches, and understand the difference in how they work and what they were there for. And then obviously you have to train your managers on the TPM principles and what the goals are so that they are able to coach and mentor associates on the plant floor, and that they understand the investment in time and resources in implementing TPM.
Mm-hmm. Mm-hmm. Talk about maybe I don't know if you have a story or an example. You don't have to use company names or anything like that, but
sure.
Maybe tell us about one TPM implementation that you saw there, maybe kind of as they began, and did they start with 5S, and how did they get things rolling?
Well, I'll go back to when I was with the Tier 1 automotive supplier. When I first got there, we were installing our third cell, and I can remember a time as a maintenance manager, we had all three cells down at once. I mean, we were producing zero product. We had significant equipment reliability issues at the time. Mm-hmm. And, as we began the lean journey, we did implement 5S first. That was the first place we started. But then we also identified that, equipment reliability was going to be extremely important. So, like I said, we implemented this tactile environment to train folks. And then as we were able to teach operators on the floor how to identify failure modes, wear items, and things like that, it gave maintenance more time to be able to spend on equipment improvement teams, which is a big piece of TPM. You want your maintenance folks to really be improving equipment, not just maintaining it.
Yeah.
And so what we were able to see is we broke out more and more time for maintenance to focus on those things that were holding us back. Mm-hmm. And our maintenance team, with the help of a couple of engineers within the department, were able to redesign the cranes in that area, which significantly reduced the downtime, and obviously uptime was improved. Then we were able to take a look at other equipment. Now, one of the things that was really important to that transformation is capturing the data via work orders and really using that data to analyze certain situations. So where were you seeing the most downtime? What had the most impact on production? And we had folks whose job it was to specifically look at that and plan additional events, whether it be improvements or improved PMs. And every time we made a step towards implementing more and more TPM, we saw more uptime, we saw more operator involvement, to the point where we ultimately got to a 4-hour per month. Every month we spent 4 hours in a cell. And that preventive maintenance activity was, full-time PM guys, maintenance guys, operators, even janitorial was involved. We had engineers involved in that 4-hour block of time where we were really going through that cell and looking at every wear point, replacing filters before they fail, replacing wear parts before they fail. And we actually grew into the point where we were using oil analysis and vibration to predict when bearings or when hydraulic fluid was getting ready to fail so that we could replace it and not have problems in the future. Mm-hmm. And really following the foundation of 5S and getting everything in its place first, mm-hmm. and then moving forward through the pillars, we actually saw a significant transformation. We were able to reduce our inventory budget 4% year over year for about 4 years in a row. Mm-hmm. And our mean time between failure and mean time to repair both improved by more than 50% during that time frame. So mm-hmm. It was really, really a huge transformation. And I've seen similar transformations in other organizations that I've been a part of.
Yeah, I remember one company that I worked at in the past, the maintenance crew who really big into TPM, and they used to always monitor kind of that relationship between preventive maintenance, the amount of time spent on preventive maintenance, and the amount of time on preventive maintenance. And the idea was obviously that you want the predict or the breakdowns, if you will, that line to be going down, and
Sure.
and I always thought, gosh, it takes a lot of discipline though, to stop the line and say, you know what, we're going to work on some things here for an hour, and we got parts to make. Well, yeah, but we better take care of things right now. Otherwise, if this thing goes down, you're down for a day or two. Versus a few hours. So it takes a lot of discipline and courage, really, from leadership to adopt this mentality.
And I'll tell you what we used to say all the time, and I've said this over the years when we're working on a TPM implementation. You've heard the phrase "pay me now or pay me later."
Mm-hmm.
In the maintenance world, it's generally "pay me now or pay me a whole lot more later."
Yeah.
And I think if people will embrace that, they'll understand that the investment in time and materials and labor is certainly an investment in the future.
Yeah. I mean, just think about your car. You don't change the oil, every 3,000 to 5,000 miles. Your engine's going to blow up, and then you're really
Absolutely.
in trouble.
Absolutely.
So yeah. Okay. Hey, talk a little bit about maybe some of the mistakes that you've seen over the years as it relates to TPM.
Sure. I think, when you think about TPM, probably the most common mistake that people make is underestimating their maintenance skill. So we're talking about being able to train associates who are operating equipment, associates who are doing assembly and things like that on how to identify failure modes within their area of operation. And if your maintenance associates are not at a particular level, they're going to struggle with training those folks.
Mm-hmm.
And so you have to look at it two ways. First of all, how familiar are your maintenance folks with these operations, and how much can they train? And then what is their ability to train? So I think that's one place that organizations really need to think about is, if you have the skill set within your maintenance department, make sure you have a good trainer that's going to transfer that knowledge to your associates.
Mm-hmm.
The second thing is making sure that when you are training your associates, that you're training them on those things that are specific to your organization. If you're not a PLC-rich environment, don't spend time working on that. If you don't have a significant amount of hydraulics, don't spend time working on that. Train them on the equipment they use every day and the components that are in that.
Mm-hmm.
Train them on the things that you've seen over the course of your PMs and your PDMs that are wear components, so they know how to look for it. Another big mistake that I think companies make is they don't allow ample time for the program to be successful. So somebody wants to implement TPM, and in a month or two, they don't see a significant improvement,
Mm-hmm.
and they think it's not working. Well, TPM is going to progress over time, and it's not straight line improvement. The more you invest in TPM, the sharper that curve becomes towards improvement, because your people learn more. Then your maintenance has time to analyze more. Then you put more improvement teams together, and that curve really sharpens the more you do. So you really have to invest time for the program to be successful, and expect it to take you a year to really see that huge improvement that you're looking for.
Mm-hmm.
And then also don't underestimate the cost, because you're talking about improving your equipment as far as, I kind of look at it like vintage cars, right? So you want this really nice vintage car, and you're not going to get a vintage Corvette that's show worthy that just came out of somebody's barn unless you spend the time and spend the money to get the original manufacturer's parts in there, to get a good paint job and those kind of things. You have to understand that when you're bringing your equipment back up to standard, and then you begin to improve it, there is some investment in dollars that goes into that. I think people underestimate that.
Yeah. Hey, you mentioned PM and PDM. Talk a little bit about what those things are, and maybe what you need to be thinking about if you want to be successful.
All right. So first of all, PM is preventive maintenance. So that's what generally companies will do today, what they call their sustainment methods. But when you think about preventive maintenance, that only goes so far. So it's changing oil, changing filters. A lot of times PMs in today's world are text-based, and they're really going out and looking for things that are broken, right? Well, the downside to a traditional preventive maintenance program is most people aren't able to really follow text-based information as well. So when you get into really focusing on PM, you want to try to get it as visual as you can, take pictures of your equipment, take pictures of failure modes, and that will help to drive it. But really what you want to do is take that PM information and drive it into what I call PDM, or predictive maintenance technologies. If I can predict based on a delta P for pressure when a filter needs to be changed in an HVAC unit, then I can save a significant amount of money. If I do it time-based like a traditional preventive maintenance program, I'll change that filter 12 times a year whether it needs it or not.
Mm-hmm.
But if I'm not running that system, I may only need to change that filter 7 times a year based on that delta P. So predictive technology and predictive maintenance comes from understanding your wear parts, using vibration analysis to know when a bearing's life is coming to an end based on the frequency that bearing's running on high-speed equipment. Mm-hmm. It's tribology, knowing how long that hydraulic fluid's going to last based on the pressures and the heat that's involved in that hydraulic circuit. When you use that predictive maintenance versus traditional preventive maintenance techniques, then you can estimate when those things are going to fail, and you can get out in front of them, and then you have a better opportunity to plan the corrections, so that, you were talking earlier about planned versus unplanned. Industry standard says they want 80% planned work, 20% unplanned. Mm-hmm. And to get to that number, you really have to focus on predictive technologies and predictive maintenance principles to get there. You have to focus on what's going to fail and understanding how to get that information before it happens.
Now, you mentioned pressure, like things with like an air filter and whatnot. What are some of the other predictive technology tools or systems that you've used and that you've seen work?
Well, there's a number of them. I mean, one of the biggest ones that we used in our industry in automotive was thermographic imaging. So if you think about using thermographics on your switch gears, on your main panels, on your equipment, you can identify a number of areas that tend to be very costly when they fail. Mm-hmm. But even thermographics goes much further than that, because you can look at a process under a thermographic camera and identify if there's a problem within that process where things are generating heat. You can identify leaks in a building using thermography on a roof to understand where water's puddling inside the seams of a roof. So there's so many different ways you can use thermography. Other predictive technologies, like I said, you have vibration analysis. Mm-hmm. Vibration analysis and ultrasonics working hand in hand. You can look at bearing life. You can look at leaks under ultrasonics for air. So there's those kind of things. But then the other thing for predictive is doing an analysis on your equipment and understanding failures. So, a real world example for us in the automotive industry, we're making micro V belts. And while there was no way to actually use what we would call technology to see this, all of our builders had a pin, and they were rotating 1,200-pound molds. And over time, we knew that these pins were only going to last so long. And the reason the pins wore out quickly is because they were designed softer so they didn't affect the equipment itself, because the pin was easily replaced. So understanding those kind of things still falls under that predictive understanding. Is I know that this pin isn't going to last more than 30 days. So every time we have a PM, we're going to just replace that pin mm-hmm. and move on. We're not going to think about it anymore. And having that information still goes along with your predictive methodologies.
So when you're talking about something like thermography, how is that being done though on machines? Is it just like always certain things always being monitored, or do we have regular intervals where we're going around and monitoring various things? How does that work?
Sure. Now, in our environment, we had a company that came in and shot the plant every quarter, and some people would say that that's maybe more frequent than you need, but we found issues every single quarter. And so what we did was they would come in for a day or two, we would open up each piece of equipment as we went through, and they would shoot that as it was running. Mm-hmm. And again, it's important to shoot it while it's running, because that's when you're going to find the failure modes. You'll find things, fuses that are getting ready to blow, loose lugs and generally a loose lug is 9 times out of 10 your problem. And that loose lug can create a significant amount more load, increase your temperature, which will cause failure not only in the fuses, but it can also cause a failure in the system itself, which again becomes more costly.
What performance indicators are you looking at in a TPM program?
For me, in TPM program, initially, you're going to want to look at mean time between failures. So if you take a particular asset, if it fails today, when is the next time it's expected to fail based on your history? Is it a day? Is it a week? Sometimes when we began our TPM journey, we were seeing mean time between failures that was measured in hours.
Wow.
Which is obviously not a good way to run your business.
Yeah.
So once you understand that, the next piece, as you begin to implement TPM and you're generating work orders for failures and PMs, you want to understand what's your mean time to repair. How long did it take a maintenance guy from the time this piece of equipment failed to the time he got it back up? Understanding that time frame is important because it also tells you how well your maintenance guys are doing as far as diagnosing the problem and certainly ultimately correcting the problem. Now, in order to really truly understand what's going on, we did a wrench time study. We had a couple of folks that we trained on time studies and surveys, and we had them follow maintenance guys around for days. And they indicated every time they were turning a wrench, every time they were taking a break, every time they were looking for parts, if they were scratching their head studying a problem, they indicated, they would write that down and document it. And then we were able to take that and group all that data together and find out, hey, we need to do a better job at root cause analysis. We need to do a better job at organizing our parts so they're easier to find. Or we may need to stock different parts because some of these parts that we're looking for we don't keep. And so it really helped us be able to get into that understanding really well.
All right. So when people think of TPM, obviously something typically pops into the conversation, and that is OEE, overall equipment effectiveness. Very hard to say quickly, but OEE. Talk about OEE and how it fits into the whole TPM methodology.
Okay, so I'm going to tell you my opinions about OEE. And so OEE is overall equipment effectiveness. It's really 3 pieces. So the first piece of the OEE calculation is your efficiency. If I'm supposed to make this many parts an hour, did I? So let's assume that a piece of equipment needs to make 100 parts an hour. Truly makes 100 parts an hour, your OEE, your efficiency in your OEE calculation is 100%. If it only made 90 parts, it's 90%, so on and so forth. The second piece that goes into OEE is the quality. And now it's really important when you talk about the quality measure in OEE, we're talking about first pass yield. It's not, they're not measuring how many good parts did you ship today, which is important. But in the OEE calculation, we want to know first pass yield. So I made 100 parts, 100 of them never had to be touched in the process. They went in a box and they were fine. My quality measure is 100%. If I had to do anything to those parts, rework or anything, then that number would be reduced. The third piece is equipment availability. And so let's say, for example, that same piece of equipment has a 480 minutes of available work time. If I take out breaks and lunches, I'm left with 480 minutes. Now we're measuring availability, not actual run time. What we want to know is, if I need that piece of equipment, can I use it? And so the things that would be taken out of that calculation, any downtime related to maintenance, for example, I had to change a cylinder or I had a PLC go down. Any of that time, you want to capture that in minutes, reduce that from your overall amount, and then that would be what's left of your availability. Now, when you're managing availability, you need to think in terms of 2 things. Idle time is the time that an operator should be running that machine but isn't. So that would be part of your efficiency calculation. Downtime is the time the machine should be available to run but isn't. So I want to make sure I make that distinction. Idle time goes in efficiency, downtime goes into the maintenance piece. And so then what you do is you take those three numbers. So let's say I got 100% on efficiency. I made 100 parts. All of them are good. I'm 100% there. But my machine was down for a while. So, I'm only at 70% efficiency there. We're going to multiply the three of those together, and we're left with our OE calculation. Now, that's the general understanding of how OEE works. Here are some things where people make mistakes. It's really important when you implement, when you're looking at OEE, to make sure you have good measures for efficiency. You really truly need to understand how much can this machine make, and are we making that? And you need to make sure that you have a method for capturing that data. As important, but somewhat more difficult, is how do I measure first pass yield? Am I measuring first pass yield by relying on an operator to check a box when things don't work? Am I collecting all that data at the end of the day and putting it into a system where I can use it? Or is it gut feel? Well, we think we made 100 good parts, but we might have only made 95 good parts. And then when you get into maintenance, obviously having that documentation, how much downtime did you have? Are you using a work order entry system to capture that? If you have those pieces and you use them effectively, then the OEE calculation can really mean a lot in terms of your TPM. One of the things I would be wary of, if you don't have a good way to measure your defects and measure your downtime, measure your efficiency, be careful with the OEE calculation. The reason I say that is because you're going to, in most organizations, you'll use that information to make decisions on what you're going to work on. Mm-hmm. And if that information isn't comprehensive and accurate, then it could point in the wrong direction. So you need to be careful of that when you're thinking about implementing an OEE calculation. And then the last thing I'll say on OEE is, if you have an assembly line, there is some value in understanding OEE on every single piece of equipment on that line. But you really want to think in terms of the theory of constraints. If you have one piece of equipment on that line with an OEE of 60 and the rest of it's 90 or 100, focus on the one that's 60. Don't worry about measuring the rest of them until you get that constraint figured out, and then go and put energy into the remaining equipment, either upstream or downstream, where it makes sense. So those would be my opinions on OEE.
Yeah, so I want to get your thoughts also. It was my experience back in the industry that the hardest part of OEE, and you kind of alluded to this, was tracking performance. So I used back in the day everything from, whiteboards next to machines to, in one situation we had spent a lot of money, let me say a lot of money on computer-based tagging systems where monitors were beside pieces of equipment, and if things were down or they had a quality problem or whatever it was, they tagged things, as we said, and it was very sophisticated software running behind the scenes. And honestly, there was pros and cons to everything. The whiteboard on a spreadsheet was one thing, and you thought the software would be, that's the way to do it, and it did work in some cases. But obviously, if you're relying on folks to enter things, it's still a person, and it's just how are they entering it. So be curious to hear your thoughts on the best way for folks to monitor OEE. Like, is it literally grab a pencil and paper or spend some money on computer-based tagging programs?
Well, I'm going to say this because, in traditional lean, the Japanese would say if you can't do it manually, you can't do it electronically.
Yeah.
Right?
Mm-hmm.
And so I would tell you that the first thing you need to do is focus on the process. How are we going to collect the data, and what are we going to collect? Mm-hmm. If we're collecting efficiency, it's pretty obvious. If your cycle time is supposed to generate 100 parts per hour, and you only produce 90 per hour, well then
that's straightforward.
Pretty straightforward calculation. And one way that you can begin to track that is have somebody who's responsible for documenting that every single hour. Mm. And it's really important. We alluded to this at the beginning, training management, training the leadership. It takes a commitment from leadership to go look at that board and say, did we fill this information out every hour? Mm-hmm. Take that to the next level. And if you didn't get 100 pieces like you expected, why didn't you get them? Mm-hmm. Was somebody off the line? Did we have a failure mode somewhere? Because one of the things you might find out is hey, we only got 100 or we only got 90 pieces this hour instead of 100, but we only got those 90 because this piece of equipment was down, which is going to be a ding both against your productivity and your equipment reliability. So you can start manually, identify the things you want, take your quality the same way, identify what you want to capture. If a product has to be pulled off a line, that's a ding against your quality, right?
Mm-hmm.
Most organizations would say if you're trying to measure ppm, you're going to talk about every single defect that had. But in terms of your OE calculation, it's really only one ding. I pulled the part off, I put it back on, that's one ding.
Mm-hmm.
If I have to pull the same part off the line later on again, that would be a second ding. But again, you can do that manually as long as you have, like you said, a whiteboard in place, and then you have specific people who are responsible for going and looking at that on a regular basis,
Mm-hmm.
and that you're genuinely doing that activity.
Mm-hmm.
Once you have developed those tools at the line, you can begin to use your information systems folks to develop, whether it's SharePoint or Excel based or any other tool. You can begin to use those tools to start to collect that data on the line electronically once you have the habit of doing it on a regular basis.
Yeah.
The maintenance piece actually becomes a little simpler for those folks using a CMMS or a computerized maintenance management system. And one of the rules we've had in every plant that I've either managed maintenance engineering or where I've been plant manager or general manager, the rule we had is no work order, no work. And I made that very clear up front in every organization that I've been responsible for. If a maintenance guy knows that you're going to support him to not work on a piece of equipment without a work order, then he will insist on having that work order before he turns a wrench. And if an organization can live with that rule long enough to get it fully integrated, fully ingrained in everybody's, the operators, the supervisors, all the way up to the top management, if you can live with that long enough to get that integrated, then you will have a much better time at managing your maintenance downtime and managing the calculations for OEE, because you'll get good information, because maintenance guys are generally pretty good about documenting when they have a work order.
Mm-hmm.
What they hate is putting in work orders.
Yeah. Good stuff, man. Well, hey, this is making a really fun talk. TPM, I'm not sure, to be honest with you, this is episode 180, and we may have touched on it in one of the previous episodes, but not a lot. So I'm really glad that you came on and shared your knowledge with us. So good stuff, Jeff. So let's go ahead now and transition into the reflection section. So this first question is kind of an oldie but a goodie, and as you know, in Lean we spend a lot of time talking about those two big pillars of the so-called TPS house. One being continuous improvement, that the tools, the things that we can do and touch, but that other pillar is respect for people, and that can be a little bit harder to define. So I'm curious to hear, what does respect for people mean to you, Jeff?
Well, I think everybody always says dignity and respect, right? So obviously you want to treat people with dignity and respect regardless of position or background. But the way that I've always said this is, and I've led a number of groups, whether that group be direct reports, indirect reports, facilitating Kaizen or TPM events, anything like that. I've always told the groups that I've been working with that regardless of who's currently in this room with us, if anyone enters that room, the collective IQ goes up. Because whoever comes in that room, it doesn't matter if they're a janitor at the organization or if they're a director at the organization, they have particular experiences and a background that everyone else in that room doesn't have. And so when you can really leverage everyone in the room's experiences, then the possibilities for solving problems becomes endless. And when people know that you're the kind of person that you want to have an organization that does leverage those experiences and does give people credit for those experiences and understand that, then you're going to have a much more positive workforce, a much more loyal workforce. And to me, that's really what respect is understanding people's experiences and leveraging those and helping them understand that those experiences are important. They're important regardless of their position in the organization.
What's the best advice you've ever received?
So Advice. When I was in the military, I had a lieutenant. He was our platoon leader. And if you ever came up to him and said, "Sir, we have a problem," the first question he would ask is, "What's the solution?"
Hmm.
And if you didn't know the solution, he would say, "If you don't know the solution, then you don't fully understand the problem." And that has stuck with me for years and years. And I think that it still rings true today. So, if you're facing a situation, whether it's at home or at work or, with some piece of equipment, and you don't know what to do to solve that problem, you need to dig more into it. You need to fully understand that problem. So, because as you understand the problem better, then the solutions will start to surface on their own. You don't have to go hunt for them. And so for me, that was one of the best things that I've ever heard is if you don't fully understand the solution, then you don't fully understand the problem.
Can you think of an experiment or a project that didn't turn out quite like you hoped? And if so, what did you learn?
Well, we just actually had one recently that I thought was actually pretty simple, and it's going to sound simple when we talk about it, but you'll understand when I get through it. But so we were working on a 5S implementation at a factory, and one of the goals of 5S was to eliminate all the personal toolboxes in the facility. And so I had made the comment in front of a room full of people that one of the goals was to do that, eliminate all the personal toolboxes. And I didn't elaborate on it too much. And so by the time we got to our third class of the day, because we were doing classes in groups, right? By the time we got to our third class, the first thing anybody said when they came through the classes, "I heard we were getting rid of toolboxes." And so, obviously I asked the question, well, what makes you think we're getting rid of toolboxes? Well, so-and-so told me we're getting rid of toolboxes. And I said, well, no, we're not getting rid of toolboxes. We want to take out personal toolboxes. Well, ultimately we that made a lot of people upset. And believe it or not, by the time we had finished training that day, some folks had already loaded up their toolboxes in their trucks and were getting ready to take them home, and everybody was upset. And so it really turned into this big deal. And ultimately what we were trying to do is not eliminate toolboxes. We were trying to eliminate personal toolboxes so that we could standardize to a particular kind, standardize to a particular set of tools. And certainly the group wasn't going to do that without getting input from the operators of what tools they needed. It wasn't, so it turned into this big deal. And so what I learned from that is say what you mean, right? Say what you mean. If you mean that you want to standardize toolboxes throughout the facility, say that. Because what you say to a group, if they don't fully understand it, can turn into this big deal, especially when you're dealing with folks who have no experience with lean and no experience with standardization. It becomes really important to say exactly what you mean, or you may cause some drama you didn't mean to cause, which could, in fact, affect your ability to implement these techniques.
Yeah, and in addition, why are we doing this, right? Like,
right.
The why is always so important,
Right.
especially when it comes to so-called moving people's cheese, right?
Right.
Yeah,
Yep.
good stuff.
Yep.
Hey, so what are you most proud of as it relates to your lean journey?
Well, I think, I've spent a lot of time in management and in lean, and I've spent a lot of time in groups. And, my wife, who's an HR manager, has helped me out with this significantly, is how to relate to people, how to respect their opinions and their experiences. A lot of times it's important to keep your mouth shut and listen. And that can make all the difference in the world. And I think what I'm most proud of in my lean journey is learning to like Covey said, seek first to understand and then to be understood. Didn't work so well in the toolbox thing because I made a mistake there. But yeah. That is one of the things that I really try to focus on is, listening to folks and relating to their issues and understanding where their hardships are so that we can help them fix it.
Mm-hmm. Earlier in the show, you mentioned an important book that influenced your TPM journey. Maybe you could mention that one again, but I'm curious if there's any other books that you've read recently or maybe you're reading now that might be worth folks checking out.
Well, sure. I actually just finished reading a book that my wife had recommended for me. It's called The Four Agreements. It's by Don Miguel Ruiz. And this book talks about, the first thing he talks about is domestication. And, we use that word for things like pets and dogs and things like that. But what we don't realize is throughout our life, we're domesticated. We're domesticated by teachers and parents and siblings and friends and churches and communities and things like that. And so what happens in our lives is a lot of our responses to certain things become automatic. I'm a Democrat because my dad was a Democrat, or I drive a Ford because my dad drove a Ford. And we don't realize that we're more a representation of the environment that we grew up in than maybe who we want to be. And so the book talks about spending some time understanding who you really want to be, and then you make 4 agreements with yourself. Be impeccable with your word. Have integrity. Say only what you mean, and avoid saying bad things against yourself or other people. He talks about not taking things personally. Don't be a victim. Most of the time what people say about you is more a projection on themselves and how they think about themselves than it has anything to do with you. And if you remember that, you'll be better. Don't make assumptions. Have the courage to ask questions and truly get the information you need to make decisions. And then the last one is to always do your best. If you choose to always do your best, and you know in your heart you're always doing your best, regardless of the reaction or input you get from other people, you're going to be able to have less self-judgment, less self-abuse, less regret, because you know you're doing your best. And then when you're doing your best, understand that today's best may not be the same as tomorrow's best, depending on how you feel emotionally, how you feel physically, things like that. And this book has really helped me to really think about life a little differently. And, when you put that into your home life and your work life, it certainly has made a difference for me. So that book, I think, is one that's had the most impact on me this year.
What's the name of it again, and the author?
The 4 Agreements, and it's by Don Miguel Ruiz.
Okay. Yeah, we'll link to it. I want to check that out. That sounds really, really good. Really good. All right. Hey, Jeff, last question. So you've been at this lean stuff for quite some time and have got an incredible background, tons of experience. But I'm curious, is there one knowledge or skill area that you feel you need to improve in order to become a better lean thinker?
I think probably the biggest thing I need to do, and the older we get, the better we are on this, but it's asking leading questions, asking open-ended questions instead of closed-ended questions. And I think regardless of how long we've been doing this, if you have a significant amount of experience in engineering or in a particular field, then you have a tendency to want to go ahead and start solving problems before you've asked all the questions. And no matter how hard I try, I mean, I was just doing a value stream map, like I told you, with a client on Monday, and I was right in there, the same thing, wanting to solve problems before I've asked all the questions. And I've been doing this for a long time. So just continue to remember that, asking the leading questions, asking the open-ended questions, and letting people just flow. And then making an effort to listen for the content during that flow that matters. And I think that's a skill that we could all work on.
Well, and it plays right into your answer to respect for people is leveraging the talent in the room, right? And if it's you up there throwing up at the mouth, you're not leveraging their talents, right, fully. So, yeah, exactly. Awesome. Hey, Jeff, let's go ahead and wrap the show up with you sharing some final words of wisdom. And then why don't you tell people how they can best connect with you?
Sure. Final words of wisdom: don't stop. Continue moving forward. You're going to have some times when you're in your lean journey, whether it's 5S, just in time, Kanban, TPM especially. You're going to have some times when things feel like they've plateaued. When they get there, have a new training. Bring some folks together. Have a meeting. Maybe even have some kind of celebration to that for reaching that plateau in the first place, and re-energize your folks. But don't give up, because the ends do justify the means. Keep pushing forward is what I would say. Couple ways that people can get connected with me. Obviously, I'm on LinkedIn, Jeff Gregory with OPX Solutions, and then our website, opxsolutionsllc.com. The 2 best ways to get in touch with me on social media. I'm also on Facebook under Jeff Gregory as well. So.
Good stuff. Well, we'll link to everything in the show notes. Folks can find that at gembapodcast.com, and this will be episode 180. So, yeah. So, Jeff, hey, good stuff. Are you going to get out to AME or any of the other conferences this year?
Yeah, we'll be at AME, and then we're also working on a speaking engagement at Industry Works in Raleigh for May.
Well, I know where you'll be Tuesday night at the AME show, right? And that's Gemba Academy's cocktail party, right?
Exactly.
All right.
Exactly.
I can't wait to meet you, Jeff. Hey, thanks so much for coming on to the show. And, I'll see you in Boston here in a couple months.
All right. Sounds great, man. I appreciate it. Thank you so much.
All right. Take care.
You too.
Thanks for listening to the Gemba Academy podcast. Now it's time to take a free, no strings attached, fully functional test drive of Gemba Academy's School of Lean and Six Sigma over at GembaAcademy.com. Gain immediate access to more than 500 Lean and Six Sigma training videos free of charge at GembaAcademy.com.